Cold Math fans. Welcome to lesson 3. Today we're talking about triangles. Notice the triangles. See what I did there? All right, they're not really triangles. They're kind of swaying triangles. I tried. See what I did there? Today's LEQ, how can we compare and contrast triangles? Like this one, or this one, or this one, this one, maybe that one, or that one. Okay, check this out. We're going to use 3 sheets of patty paper. I want you to draw the right triangle that appears similar to this one. So take a second, use a straight edge, and construct this triangle with a right angle, angle X, and angle Y. You can pause. I'll wait for you. Okay, welcome back. I want you to copy the outline of angle X on the second sheet of patty paper, and then on the third sheet of patty paper, copy the outline of angle Y. So you should have a triangle on one sheet, angle X on one sheet, angle Y on the other sheet. Place those 2 angles, angle X and angle Y, next to each other. So one sheet's going to lie on top of each other. I want them to be adjacent so that they share one side. What do you recognize about those 2 angles in relation to the original triangle? You should see something kind of cool in a geeky kind of math way. Triangles by sides. We can name triangles according to their sides 3 different ways. Just like angles, we can classify them to be scalene, isosceles, or equilateral. Just joking, we don't classify angles by their sides, we classify them by their angles, but classify them 3 ways. So, if I have a scalene triangle, that means that my triangle contains no congruent sides, and it looks like this. I put these little marks here to show that no 2 of those sides have the same length. I can have an isosceles triangle, and that means that the triangle contains at least 2 congruent sides. So in this case, these 2 sides are congruent, but not equal to this. When I say at least 2 congruent sides, that should be throwing up a red flag, meaning that maybe a 3rd side could be congruent, which brings up equilateral triangles. It's a triangle that contains exactly 3 congruent sides. I don't know if you can see it down here, but we use tally marks to indicate whether sides are congruent to each other. I wouldn't want to confuse that these 2 sides are not congruent to this side, so these get 1 hash mark, that's congruent to that, but this has 2 hash marks, not congruent to either one of these. Here's where we can sort our triangles by angles, similar to sorting by angles. I can have a right triangle, an obtuse triangle, or an acute triangle. Every triangle has acute angles in it. It's a question of having other angles in it that differentiates it. A right triangle has exactly 1 right angle. It doesn't matter about the side lengths. I'm just interested in seeing that it has 1 right angle. And it can be in any orientation or any position. Obtuse triangles contain exactly 1 obtuse angle. So in this case, you can see by this right angle or perpendicular mark that this is greater than 90 degrees. Same thing with this triangle. Or I can have acute triangles that contain 3 acute angles. All of them are less than 90 degrees. Here's your first example. Draw a triangle with 1 obtuse angle and no congruent sides. you should be able to construct a triangle with specific parameters. And then classify the triangle by its angles and sides. So I'm going to draw an obtuse angle. The two sides of the angle should have different lengths. And then I'm going to connect the two segments to form a triangle. That is my obtuse scalene triangle. Try this one. Draw a triangle with a right angle and two congruent sides. Here's my right angle, my sides are congruent, and I connect it. I indicate that these two sides are congruent with one hash mark. Classify a triangle that's part of an image based on its angles and sides. If I show you this roof line and ask you about the triangle there, you should tell me that the triangle has a gable that's made up of two congruent sides and an obtuse angle between them. This part of the roof is an obtuse isosceles triangle. Try this one. Classify the triangle in the image by its sides. What can you tell about the roof line? It's a scalene triangle. None of the sides are the same. Here's a little FYI for you. The Americans with Disabilities Act, or ADA, standards require that ramps have a 1:12 ramp slope ratio, which equals a 4.8 degree slope on 1 foot of wheelchair ramp for each inch of rise. So whenever you see a wheelchair ramp, it's actually constructed of what kind of triangle? That's right, it's a scalene right triangle. 30 feet, 30 inches. The ramp has to be longer than the length down here, and that is a right triangle. Now you know. See you soon for another episode of Stone Cold Math.